and then we'll talk about the tests at the end of class. All right, so today we're talking about section 5.5, which is called rational functions and rational inequalities. We're really just going to be talking about rational functions today. I didn't include anything about rational inequalities, so we're really not talking about those today. That's just the name of the section. So let's talk about what a rational function is. I'll talk about what an asymptote is, and then I'll tell you how to find the asymptotes. Okay, so section 5.5, our last section of this chapter, talks about rational functions. So a rational function has the form f of x equals, it's just a ratio of two polynomials, or a quotient or a fraction of two polynomials. So f of x equals p of x over q of x, where p of x and q of x are polynomials. Okay, so just a fraction with polynomials in the top and in the bottom. One special characteristic or feature of rational functions is that they have asymptotes. So asymptotes, there are three types, but asymptotes are lines on the graph where the function is undefined. So these are lines on the graph where the function is undefined. So three types of asymptotes we're going to talk about are vertical asymptotes, so those will be vertical lines, horizontal asymptotes, which of course are just horizontal lines, and then we'll talk about oblique or slant asymptotes, and those are going to be, just like linear equations, stuff like y equals 2x plus 3, so slanted lines. So three types of asymptotes that we'll be finding today. Vertical asymptotes are the easiest ones to find, and then horizontal asymptotes, there's really just two rules for those, and then oblique asymptotes are the most difficult to find, or the most work to find, I should say. All right, so let's talk about vertical asymptotes real quick. These are vertical lines. They always have the form x equals some number. All right, and then to find vertical asymptotes, here's your step-by-step guide. Step 1 is to factor top and bottom, if possible. So factor the top and the bottom, if possible. Vertical asymptotes are the only type of asymptotes that you'll have to factor for. Everything else you don't have to worry about factoring. And then the second step is cancel if you can. So cancel common factors if you can. So we'll just say cancel common factors if possible. And then our last step is going to be where we find the vertical asymptote. So step 3 is set denominator equal to 0 and solve, and that's going to give you the equation for your asymptote. So if you have a denominator left, sometimes you'll get lucky and the entire denominator will cancel out. You won't have to worry about finding a vertical asymptote. So if you're left with a denominator, then you'll go on to step 3 and you will set your denominator equal to 0 and solve. If you've canceled out your denominator, you don't have to worry about it. There is no vertical asymptote. All right, so let's jump over if you'll flip the page over. We're going to come back and do these, but let's flip the page over and let's do number 1. All right, so number 1 says find the equations for the vertical asymptotes, if any, Yeah, there's notes up here if you didn't grab any. So find the equations for the vertical asymptotes, if any. This word in here, equations, is important. We'll talk about why that is in just a second. So find the equations for the vertical asymptotes, if any, for the rational function. And then we have our two rational functions there. Part A is negative 4x squared minus 5x plus 6, and then our denominator, negative x plus 6. All right, so what you have to do here, step one, remember, was factor the top and the bottom if possible. The denominator here is, it can't be factored, so we'll just look at the numerator. Let's go off to the side and do this kind of like as our scratch word. So we're just going to jump over here, and I'm going to rewrite that function. Okay, and we're going to factor this. We're going to use the AC method to factor. We're going to be factoring for the rest of the semester, so it's really important that you get good at factoring. So we have A times C is negative 24. So negative 4 times 6 is negative 24. So you're trying to think of factors of negative 24, so things that multiply to give you negative 24 but add to negative 5. What would that be?
8 and 3.
Good. 8 and
negative 8 and positive 3.
Very good. Negative 8, positive 3. Right, so that's how we split up our middle term. Negative 8x plus 3x. Everything else is going to drop down. So negative 4x squared plus 6. Now we got 4 terms, so you're going to group them together, factor by grouping. Group the first two, group the second two. First two, second two. What should we factor out of the first two? What is the common factor here?
Negative 4x.
Good, negative 4x, very good. You're always going to pull an x out of the first two. All right, so let's see, that leaves you with an x plus 2, because that flips the sign because we pulled out a negative number. And so we want to get another x plus 2 over here, so we should factor out a what? A 3, good. And we're going to make that a plus 3. That's just going to help us with the next step if you go ahead and put that plus in front of that. And that leaves you with an x plus 2. So pull out that common factor. The x plus 2 goes out front. The leftover stuff goes in the next set of parentheses. So that's negative 4x plus 3. All right, so all this work, all this factoring, is just to see if we can cancel out something in the denominator. So let's write it up here, see if anything in our denominator cancels. All right, so does anything cancel out of the denominator? No, it does not, right? Nothing in here cancels, that's fine. If nothing cancels, then your next step, let's see, cancel common factors. If possible, there were no common factors to cancel, so we go to step 3, which was set the denominator equal to 0 and solve. So go over here, set that denominator equal to 0 and solve that. So what do y'all want to move over, the x or the 6? The x, that's what I would move over to. This is just going to make it easier for you. Now, if that looks weird to you, you can just flip it around, put the x on the left. And there's your asymptote. Now, if you write, I told you in the beginning, I said this word equation is really important. That's because if you just write 6 as your answer, I'm going to have to count it wrong. Because that's not an equation, that's just a number. So you have to have the x equals in there because that's what makes it an equation. So don't forget the variable, or we'll just say don't forget the x equals part. All right, so I wouldn't count it like completely wrong if you forgot to put the x equals, but I would just only give you partial credit. So Don't forget about that part. All right. So not terribly difficult to find the vertical asymptote. The worst part is this factoring stuff. All right, so let's look at part B. We're going to do the same thing. We have 5x squared plus 11x plus 6 over 5x plus 6. So take the numerator, go off to the side, and factor that. So I'm going to take my numerator, we'll go over here. 5x squared plus 11x plus 6. I'm going to factor that. So multiply a times c. So that's 5 times 6 is 30. Now, some of y'all were doing the little, like this thing where you draw this little x and do it that way. That's fine if you want to factor that way instead of doing the AC method. I just don't know how to factor that way. All right, so 5 times 6 is 30. What are things that multiply to 30 but add to 11?
5 and 6.
Yeah, 5 and 6. All right, so split up your middle term. That'll be 5x plus 6x, or you could do 6x plus 5x. It does not matter. Drop down the other numbers. 5x squared plus, filling in that plus there because there was just a little blank spot. And then plus 6 on the end. Group the first two, group the second two. Pull out a 5x out of the first two. The first group. That leaves you with what? Am I going too fast? Y'all tell me if I'm going too fast. X plus 1. And then out of the second group, pull out a what? 6. That leaves you with another x plus 1. All right, so pull out that common factor, x plus 1, that goes out front, and then what's left over? 5x plus 6, which is nice because that was our denominator. All right, so that's going to cancel out our denominator, which makes this a lot easier for us. All right, so you just go up here. Your function f of x is, let's see, factored numerator is x plus 1 times 5x plus 6. Denominator is 5x plus 6. All right, so that cancels, and you don't have to worry about finding a vertical asymptote. Your denominator's gone. So don't worry about vertical asymptotes here. No vertical asymptotes. I'm going to abbreviate that, VA. No vertical asymptotes. So if your denominator cancels, you don't have to worry about finding the vertical asymptote. Definitely going to be one like this on the test. I don't know if I'll do A or B, but we'll put a star beside this one because it's definitely going to be on the test. So my plan is to take one of the vertical asymptote questions and then either a horizontal asymptote or oblique asymptote. So one of those. I haven't decided yet which one. All right, let's go back to the front page and fill in the rest of the rules for horizontal asymptotes. Then we'll go do that problem, then we'll come back and do oblique. All right, so the horizontal asymptotes rule is kind of long, so that's why I wrote part of it out for you. It says, let n be the degree, remember the degree is the highest, the exponent. So let n be the degree of the numerator, and let m be the degree of the denominator. All right, so we have 3 possible cases here. Well, really there's 4. There's one at the very bottom. But we're just considering these 2 cases right now. We're considering the first case where the degree of the numerator is less than the degree of the denominator. All right, so again, this is degree of the numerator. This is the degree of the denominator. So if your degree of your numerator is less than your degree in the denominator, then the horizontal asymptote is y equals 0. There's no work for you to do. You don't have to solve anything. You just automatically know that the horizontal asymptote is the x-axis or y equals 0. The second case is a little bit more complicated. So if the degree in the numerator and the denominator are exactly the same, then the horizontal asymptote is y equals, very important that you get the y equals in there, y equals leading coefficient of the numerator divided by the leading coefficient of the denominator. Now that looks complicated, but this is super easy to find as long as your polynomials are in descending order. And as far as I know, I looked over the homework earlier and everything looked like it was given to you in descending order, so it should be super easy on this one. All right, so I'm going to show you just a quick example of what that means to have y equals leading coefficient at the top and leading coefficient over leading coefficient at the denominator. So I'm going to go off to the side on a separate sheet of paper here and show you a little example. So let's say we have f of x equals 3x squared plus 2x minus 7 over negative 2x squared plus 5x plus 6. Just made those up. There's nothing special about these. Well, I guess the only thing that's special is that notice that the degree of the top is the same as the degree of the bottom. Degree is the highest coefficient, so these have the same degree. So that means that we're using this case here. Degrees are equal. All right, so it says the horizontal asymptote is y equals, right? So HA horizontal asymptote is y equals. So the leading coefficient of the numerator divided by the leading coefficient of the denominator. Leading coefficient is just the number out front if you're in descending order. So that's 3 and negative 2. So it's 3 over negative 2. Super easy. Okay, so the only way that you could possibly make this more difficult is to write one of these out of order, and you would have to write them in the correct order first. But as far as I know, all of them on the homework are written in the correct order. So you won't have to worry about that. All right, but that's what I mean by, the ratio of the leading coefficients. All right, let's flip it back over. Look at number 2. Here's number 2. Find equations of the horizontal asymptotes, if any, for the rational function. All right, so first thing you need to do, this whole rule for horizontal asymptotes is all about the degree of the numerator and the degree of the denominator. So let's look at here, look at our equation, look at our function, and let's figure out what is the degree. So degree equals degree equals. All right, so look at the denominator first, because the numerator is kind of special, so we'll come back and talk about it in just a second. What is the highest exponent in your denominator? 1, yeah. So the degree is 1. And there's no variable up top, right? So you see no variables up here, so that means it's degree 0. So no variables means degree 0. So no variables means degree 0. Okay. So let's look at our rule. It says, in this case, the degree of the top is less than the degree of the bottom. All right, so that's the first rule. It says if the degree of the top is less than the degree of the bottom, then the horizontal asymptote is just y equals 0. So that's all you have to write. We'll just write, this is rule number 1. So the horizontal asymptote is y equals 0. There's no work to be done. All you have to do is identify the degrees. All right, let's check out part B. That's the same function from number 1, part B. Just copied that one over. What is the degree of the numerator? Two. And degree of the denominator? 1. Okay, so let's look at our rules. rule number 1 for horizontal asymptotes was degree of the numerator is less than degree of the denominator. Is that the case here? No. The second rule for horizontal asymptotes is if the degrees are equal. So these degrees are not equal. The top is not less than the bottom, so that means there's no horizontal asymptote here. So it doesn't fall under either one of those rules. If you look below, if you flip over to the front, this actually falls under the category of oblique asymptote, but we'll talk about that in just a second. So that function does have an oblique asymptote, but not a horizontal asymptote. So we'll just say doesn't fall under either category or either rule for rules number 1 and 2. All right, flip back over to the front. Let's talk about oblique asymptotes, and then we will be done. Oblique asymptotes, these are the most work. Oblique asymptotes, also called slant asymptotes. I'm sure you've seen this word in geometry. It just may have been a while, but this is pronounced oblique. So that's phonetically how you would spell it or write it. All right, so oblique asymptotes, this is the case that you would look for. An oblique asymptote is if your degree of your numerator, let's write that out, degree of numerator is equal to the degree of the denominator plus 1. So if the degree of your numerator is equal to the degree of your denominator plus 1, then you do polynomial division. You can either do long division or synthetic division. So we would say you conduct or perform polynomial division. The oblique asymptote is y equals the quotient. You do not care about the remainder. You only care about the quotient. So you conduct polynomial division. You would either use synthetic or long division. I'm going to show you how you can use synthetic division on both of these examples just to make it quicker for you. And then your answer is going to be y equals the quotient. Don't forget the y equals there. It's very important. Y equals the quotient. And then down here we'll just put you do not need the remainder. You do not need the remainder. And then we'll just go ahead and do this last case down here. If the degree of the numerator is more than n plus 1, which is the degree of the denominator plus 1, there's no asymptotes. No, we'll say no horizontal / oblique asymptotes. And I'll explain what that means. I'll show you an example. So I was going to say no asymptotes, but there could be vertical asymptotes. So that's why I wanted to make sure and put horizontal or oblique. So there could be a vertical asymptote, but there's definitely not going to be any horizontal or oblique asymptotes. So let me show you what that case would look like, or what that situation would look like. So say you had a function like f of x equals 3x to the 4th plus 3x squared plus 7 over 2x. All right, so here, what's the degree of the top? 4. Degree of the bottom? 1. All right, so in that case, n is 4. M would be 1, so 4 is greater than 1 plus 1, which is 2. Right, so if that's true, then there's no horizontal or oblique asymptotes. So here you would just say no horizontal asymptotes, no oblique or slant asymptotes. Right, so if that degree in the top is more than the degree in the bottom plus 1, then you don't have to worry about horizontal or oblique asymptotes. These are going to take us the longest, but I'm going to show you, this is going to be some examples to show you how can you make just some small adjustments and make anything work with synthetic division. All right, so let's zoom in and look at number 3, part A. All right, so remember, just one quick thing to remember about synthetic division. So remember, for synthetic division, remember your divisor had to be in the form x minus c. Right, so just keep that in mind. All right, so our function here is f of x equals negative 4x squared minus 5x plus 6 over negative x plus 6. So right now our divisor is not in the correct form for us to do synthetic division. We'll have to make some adjustments there, but the first thing you have to check is check the degrees of the top and the bottom. So don't forget, that's always your first step. What's the degree of the top? 2, and the degree of the bottom is 1. So you just check and make sure that that falls under the category of oblique asymptotes, and it does. It says oblique asymptotes are where you have degree of the numerator is equal to the degree of the denominator plus 1. So degree of the denominator is 1, plus 1 would be 2. So that means there is an oblique asymptote. We're going to do synthetic division here, but you're welcome if you prefer long division, which some people do. It's not uncommon to have people do long division on the test, or to choose to do long division on the test. But we got to work on this divisor. Oh, sorry, you couldn't see where I was pointing. We got to work on this divisor because of this negative out front. All right, so go over here to the side. I'm going to write the divisor is negative x plus 6. All right, so we need to be in the form x minus c. So we need that x out front to be positive. What could we, bless you, what could we multiply or divide by to change this and make it positive? Yeah, multiply by negative 1. So multiply everything by negative 1. So that flips the signs of everything. So that's going to be a positive x and a minus 6. That's perfect. The only thing we have to do now is whatever we do to the bottom, we got to do to the top. So we got to multiply the numerator by negative 1 as well. All right, that's our dividend. It's going to be our dividend when we do synthetic division. So we're going to multiply it by negative 1 as well. Whatever you do to the bottom, you got to do to the top so you don't change the problem. All right, so here's our new dividend. That's going to be positive 4x squared, positive 5x, and then minus 6. Okay. Once you've got those adjustments made, you could go up here and rewrite that fraction. You don't have to, but if that makes it easier for you to see, you could do that. But otherwise, we're just going to jump straight into synthetic division. So remember, once you have it in the form x minus c, you go ahead and identify what is c. What is c in this case? 6, good. So again, someone in the first class this morning was asking, shouldn't it be negative 6? And remember, you match the x with the x, the minus with the minus, and c matches with 6. All right, so 6 goes in the little box all by itself. And then what goes beside it right here? The coefficients on what? On your dividend. So take your dividend right here and then find the coefficients. 4, 5, and negative 6. 4, 5, and negative 6. Make sure you space them out. If you don't space them far enough out, sometimes, like if, say, for example, if that 5 was close to the 4, it might make it look like a 45. And then you would, be multiplying wrong. So make sure you space those out. Drop the first one down and start multiplying. 6 times 4 is 24. You don't have to flip any signs or anything. Just go ahead and perform the operation. 5 plus 24 is 29. And we'll go ahead and do the remainder, even though we don't need the remainder. What is 29 times 6? 170? I don't know. Do y'all have your calculator? I have one. 174? And then, so subtract 6, that would be 168. All right, but we don't need this number. You can cross it off. We don't care about that remainder. So you can always skip doing that last step because we don't need that remainder here. All right, so now we got to figure out what degree is our quotient here. So remember, you always go to the numerator. You say, okay, the degree of the top was 2. It's always 1 degree less than that. So this is just going to be a first degree polynomial. So we're going to write our x. It does not have, you don't have to write a 1 up here. If there's no exponent, because it's first degree 1. And then a positive 29. All right, and there's our answer. Only thing we're missing right now is the y equals. So just go over here. That's going to be y equals 4x plus 29. And there's your slant or oblique asymptote. It's that line. Okay. All right, so I meant to tell you this earlier on the front of this page, but this quotient should always be of the form like mx plus b. All right, so always make sure it's something like mx plus b. It should be that whole, slope-intercept form. All right, so there's our oblique asymptote. And let's do this last one. Now that you know how to do this one, it's pretty easy. It's not difficult to do synthetic division. It just takes a little bit of work. So there's our second rational function that we're supposed to be finding the oblique asymptote for. If it exists, find the degree of the top and the degree of the bottom. That's your first step. You got to make sure it falls under the correct category. Degree of the top is 2. Degree of the bottom is 1. So that means there is an oblique asymptote because you could do degree of the bottom is 1 plus 1 gives you the degree of the top. All right, so only problem here is that our divisor is not in the correct form. We need it to be in the form x minus c. So what do you think we should do? How can we get rid of that 2? Yeah, divide by 2. Divide everything by 2. So divide everything in the denominator by 2, divide everything in the numerator by 2. So we'll just put here, divide everything by 2. All right, so that's going to give you 2x squared plus 1x minus 1 over x minus 3. All right, so just divided everything by 2. That's going to put your divisor in the form that we need, x minus c. What is c in this case? Yep, 3. All right, so c is 3. It goes in the little box by itself. Can y'all tell me what to write in this top line? 2, 1, negative 1. Good. 2, 1, and negative 1. Skip a line, long straight line, drop this first one down. That's 2. 3 times 2 is 6. 1 plus 6 is 7. We don't need this remainder, so you can just cross it out. All right, then you got to figure out what is my degree down here. What should I put an x? Should I put x squared? If you just look at the top here, it's the degree 2. So this one should be degree 1. 2x plus 7. All right, then go over here to the side. How do I know to put a plus there? Yeah, because it's positive. Yeah, it's not negative, so you put a plus there. So that's y equals 2x plus 7. And that's it.
Exponent was 3, didn't the x be squared?
if the exponent was 3, then, well, just first of all, our denominator would have to be x squared. Does that make sense? Because it has to be like 1 more than the denominator. And in that case, you would have to do long division. Yeah. So if the denominator is anything like something squared, something raised to any power other than 1, you have to do long division. All right, let me stop the recording real quick, and then I will talk about the tests.